Hello friends, look at these pictures. Wow, what a beautiful pictures are. Dear children, whatever we see, whether amazing sunrise, high mountains, beautiful flowers, etc., it is all because of wonderful sense organ we have, that is our eye. So friends, today we are going to discuss about various parts of human eye, their functions, defect of vision and their correction. So friends, first part of human eye are eyelid, just like shutter of camera, which protect eye from dust and other harmful things. Next part is cornea. Cornea forms the transparent bulge on the front surface of eyeball. Most of the refraction of light rays entering the eye occurs at the outer surface of the cornea. There is a black hole in the middle of the cornea known as pupil, which regulate or control the amount of light entered in our eye. Dear children, remember what will happen if we entered late in cinema hall. Initially, nothing is visible to us. After some time, we can see things and other viewers. It all happens because when we are outside, size of pupil is less because light is more. When we come inside the hole, light is less and it takes a few seconds to adjust the size of pupil, so that more light entered in our eye and things becomes visible. Dear children, next part is iris. Iris is a dark muscular diaphragm behind the cornea. It controls the size of the pupil. Dear children, behind the pupil there is an eye lens which is also known as crystalline lens. It is converging lens in nature and it is composed of a fibrous jelly-like material. It focuses the light on the retina and real and inverted image is obtained on retina. Its curvature can be modified to some extent by the ciliary muscles. The change in curvature can thus change the focal length of the lens. Dear children, as I stated earlier, the eye lens forms an inverted real image of the object on the light sensitive screen called the retina. Retina is a delicate membrane having enormous number of light sensitive cells. The light sensitive cells get activated upon illumination and generate electric signals. These signals are sent to brain by optic nerves. The brain intercepts these signals and finally process the information for our perception. That is, it is our brain which intercept the inverted image obtained on our retina and makes us to see it erect. Children, have a look at pictures. What we understand that we can focus on distant objects as well as nearby objects using our eye, and the ability of eye lens to adjust its focal length is called accommodation. As I told earlier, the eye lens is composed of a fibrous jelly-like material and its curvature can be modified by the ciliary muscles. Hence, the focal length can be changed as per the requirement. When the muscles are relaxed, the lens becomes thin, the radius of curvature, hence the focal length increases. This enables us to see the distant object clearly. When we look at the object closer to the ciliary muscles contract, decreasing the radius of curvature and hence the focal length. This enables us to see the nearby objects clearly. Dear children, do you know how far we can see? Just think over it. Some of you might think up to a few centimeters or few meters, but dear children, you may surprise that I can see beyond 15 crore kilometer. My dear children, not only me, you can also see beyond 15 crore kilometers. We have no limit. because we can see stars, moon, sun, etc. Now, the farthest point up to which the eye can see object clearly is called far point for the eye. Far point for normal eye is infinity. A normal eye can see object clearly that are between 25 centimeter and infinity. The minimum distance at which object can be seen most distinctly without strain is called least distance of distinct vision. For a normal eye, least distance of distinct vision is 25 centimeter. Dear children, as soon as image is obtained on retina, a message signal electromagnetic pulse is sent to brain through optic nerves on retina. Our brain finally intercept the image and we can see erect image of the object. But sometime eye lens could not able to focus light on retina. It could either focus the light behind the retina or ahead of retina, which cause defect in our vision. There are basically two types of defects. One is myopia and another is hypermetropia. Let us first discuss myopia, also known as short sightedness. A person with myopic eye can see nearby objects clearly but cannot see distant object distinctly. A person with this defect has the far point nearer than infinity. Such a person may see clearly up to a distance of few meters. In myopic eye, the image of distant object is formed in front of retina and not on the retina itself. This defect may arise due to number 1, excessive curvature of eye lens, that is short focal length of the eye lens, or number 2, elongation of the eyeball. Now, think what kind of lens we will use for its correction. Students, myopia can be corrected by using a concave lens of suitable power. Let us see an example based on myopia. Here, question states that a person could not see beyond 200 centimeter clearly. That is, his far point is nearer than infinity. Now, we have to tell the nature of correcting lens and the power of a correcting lens. Here, what we will understand that person could not read a board placed more than 200 centimeter away from him. Now, here correcting lens shows the image of board at 200 centimeter, which is originally placed at infinity from the person. Hence, distance of object from lens is infinity, that is u is equal to infinity, and distance of image from the lens is 200 centimeter, that is v is equal to 200 centimeter. Now, let us use a lens equation, that is 1 upon v minus 1 upon u is equal to 1 upon f, that is minus 1 upon 200 plus 1 upon infinity is equal to 1 by f, and after solving we will get focal length is equal to minus 200 centimeter, and the power of lens becomes minus 0.5 diopter. As the power is negative, lens is concave lens in nature. Now, let us discuss another defect, that is known as hypermetropia or long sightedness or far sightedness. A person with hypermetropia can see distant objects clearly but cannot see nearby object distinctly. A person with this defect has the near point farther away from the normal near point, that is 25 centimeter. Such a person may have to keep a reading material much beyond 25 centimeter from the eye for comfortable reading. In hypermetropic eye, the image of nearby object is formed behind the retina and not on retina itself. This defect may arise due to number 1, long focal length of eye lens, or number 2, very small size of a eyeball. Now, what about its correction? Hypermetropia can be corrected by using a convex lens of suitable focal length. Now, there is another defect, presbyopia. The power of accommodation of eye usually decreases with aging. For most of the people, near point gradually recedes away. They cannot see nearby object comfortably and distinctly without corrective eye glasses. This defect is called presbyopia. It arises due to number 1, gradual weakening of ciliary muscles, and number 2, diminishing flexibility of eye lens. Sometime a person may suffer from both myopia and hypermetropia. Such people requires bifocal lenses which consist of both concave and convex lenses. Upper portion is concave for distant vision and the lower portion is convex for near vision. Let us see a question based on hypermetropia. Question states that a person could not see nearer than 50 centimeter, that is, his near point is recedes away. Now, we have to tell the nature of correcting lens and the power of correcting lens. Here, what we will understand that a person could not read a book placed at 25 centimeter away from him. Now, the correcting lens makes an image of book at 50 centimeter so that he can read it. Hence, distance of object from lens is 25 centimeter, that is u is equal to 25 centimeter, and distance of image from lens is 50 centimeter, that is v is equal to 50 centimeter. Now, use lens equation, that is 1 by v minus 1 by u is equal to 1 by f, that is minus 1 upon 50 plus 1 upon 25 is equal to 1 upon f. After solving, we will get focal length of the lens is equal to 50 centimeter and the power of lens is equal to 2 diopter. As the power is positive, hence lens is convex lens. Now, dear children, there is another defect, that is called cataract. What is the main cause of cataract? Most cataract develop when aging or injury changes the tissue that makes up the eye's lens. Proteins and fibers in the lens begins to break down, causing vision to become hazy and cloudy. Some inherited genetic disorder that cause other health problems can increase your risk of a cataract. So, dear students, in this lesson we have covered following topics: working of eye lens in human eye, defect of vision and its correction. Thanks and have a nice day.